How does an LLM's context window actually work? Imagine trying to have a conversation where you can only remember the last few sentences. That's similar to how large language models process information. They have a limit on how much text they can handle at once, called the context window. This window is measured in tokens, which are small chunks of words or parts of words. Think of tokens as puzzle pieces that the model uses to understand language. The size of this window determines how much information the model can consider when generating a reply or prediction. These models are built on transformer architecture, which uses a method called self-attention. This means the model looks at all tokens within its window and figures out how they relate to each other. It's like a person reading a paragraph and mentally noting which parts connect or influence each other. This process helps the model understand the meaning and dependencies in the text. If the input text gets longer than the window size, the oldest tokens are dropped as the window slides forward. This is similar to a moving frame that always shows the most recent part of a conversation or document. The size of the context window varies a lot depending on the model. For example, earlier models like GPT-3 could handle around 2,000 tokens at once. But newer models like GPT-4 can process up to 32,768 tokens. Some advanced models, such as Claude 3 from Anthropic, can handle over 200,000 tokens. Larger windows let the model work with longer conversations, detailed documents, or complex instructions without losing track of earlier parts. This means it can summarize long texts or keep a conversation flowing over many exchanges. However, increasing the size of the context window requires more computing power. The calculations for self-attention grow roughly with the square of the number of tokens. So doubling the window size makes the process 4 times more demanding. This impacts how fast the model responds, how much memory it needs, and how much it costs to run. Developers have to find a balance between making the window bigger and keeping the system efficient. In real applications like ChatGPT or Claude, the context window includes both what the user says and what the model has already generated. When the conversation gets too long, older parts are cut off to stay within the limit. This can sometimes make the model forget earlier details unless special techniques like retrieval augmented generation are used. These techniques help the model access external data to fill in gaps when the window is full. Knowing how the context window works is key to understanding how large language models handle complex tasks. Whether it's powering chatbots, content creation tools like DALL-E and Midjourney, or productivity plugins, the size and management of this window shape how well these models perform. It influences their ability to stay coherent, ethical, and relevant as they process more information at once.